Okay, so for takeoff distances, we're also going to use charts straight from Diamond out of the AFM. We're going to do this in class, and this is just a demonstration video in case you're having trouble doing it. We're just going to use the numbers in the example provided. This table, this graph is pretty simple. It's a lot to look at, but what we basically have here is this first box is a pressure, altitude, and a temperature, and you're arriving at one point, essentially factoring in your density altitude to determine your takeoff distance. That's the first thing. Then we go over to the second box and we have takeoff mass. We call it weight. The units there in pounds. As you can see, I've redacted all the units that were not US units. And you can clearly see that the lighter the airplane is going to significantly affect our takeoff distance. If we're lighter, the distance is going to be reduced there. And then lastly, we come over to our headwind and tailwind components. We're going to parallel those lines as necessary to the wind factor at how many knots. And once we're there, we're just going to go across, straight across, to see our actual takeoff distances. Now, it's important to note there are two takeoff distances. One is the distance for the ground roll, and one is the distance over a 50-foot obstacle. The distance over the 50-foot obstacle is always going to be a little bit longer than the ground roll. And a quick review of that right here. So if we got a runway, we got an airplane, it's going to take off. As that airplane accelerates, they're going to rotate at some point and begin to climb. The ground roll is the distance from where we begin to accelerate to where we lift off, rotate. The takeoff distance over a 50-foot obstacle is going to be longer because we're going to have to get over 50 feet above the runway. So that's just a quick explanation as far as how that works. So let's see what they've done here. In every one of these charts, they're giving you examples that Diamond actually did just to show you how to do it in case you forget, which does happen. So they're providing altimeter settings, they're providing temperatures, and pressure, altitude, so on and so forth. What they do on the first box is they go to their current temperature as provided, which is 15 degrees Celsius, and they match that with the pressure altitude provided, which is 2,000 feet. So the degrees Celsius are easy. They're listed here on the bottom. You see how they've started at 15. And they're going to go up until they hit their pressure altitude. This is a little more tricky, but you can see them listed here. Pressure altitude 0 feet. So this bottom line is sea level. This next line is 2,000 feet. And we've got 4,000, we've got 6,000, and 8,000. So they're just going to 15 degrees Celsius up to 2,000 feet here. And you can clearly see how they've done that. Once they get to that point, they go straight across to the very next chart, starting at the next box. When they get to that spot, they're then going to factor in the weight. Well, their weight they provided was, 2,205 pounds. Notice what they do here. They're going to parallel these guidelines. I call them guidelines. Parallel the lines to the right until they reach their weight of 2,200. So notice what they've done in their example. They follow the lines down until they hit this spot right here. Why do they stop here? Because that's their weight, 2205. At that point now, they go straight to the right across onto the winds. The winds are going to work exactly the same as the mass or weight did there. So we've got wind component, headwind component here. Tailwind is obviously would increase. So they're going to parallel the wind component lines to however much wind they have. They have 10 knots of wind. So you see they're going to follow the lines till they hit their 10 knots of wind. And that's where we're now at the last phase here. And you'll be using your plotters for this so that you don't just write all over these charts. You can see how, according to their data, the takeoff ground roll is going to be just under 600 feet. But if we wanted to find the distance over a 50-foot obstacle, you can see that they're actually including this entire box up to 50 on the right side. And so if we were to follow what they did, they come up to that spot and then come back across to see their takeoff distance over a 50-foot obstacle closer to 1,000 feet. So if we look back, they're going to give us those numbers here at the bottom. 558 for the ground roll, 985 for over a 50-foot obstacle. So that's just a quick rundown of this chart. It works fairly simply. Once you get the hold of this one, others will follow similar formats. And understand the numbers we get, these numbers are yielded based upon a brand new airplane under ideal conditions. So we tend to take them with a grain of salt and think that we might get that, but we might actually have to use a little bit more runway than prescribed. Yes, we're looking at 600 feet and 1,000 feet necessary. Most of these small runways, even at small airports, at least 3,000, 4,000, 5,000 feet to work with. But we need to know those numbers for FAR 91-103.